Hello friends, welcome to the Digital Electronics Practicals of FY BSC IT Semester 1. So here we are going to discuss about the basic logic gates and their ICs and how to interface these ICs. So the first practical is about study of logic gates and their ICs and the universal gate. So the logic gates are AND or NOT as they are written here. Amongst that, there are some basic gates and then there are some combinational gates. These are the IC numbers that are used for this AND gate, OR gate, etc. So we are going to implement these gates on a breadboard in terms of circuit. So let us first talk about the logic gates.
Logic gates are basically the building blocks of any digital system. They are basically the electronic circuits which have one or more than one input and one output. It is not necessary that they should have one output always. They can have multiple outputs as well. But the relationship between their inputs and output is based on certain logic. And that logic makes the different gates like AND gate, OR gate, NOT gate, etc. These gates are powered up with some voltage value, and that is 0.5 maximum voltage that you can provide to these gates. So the inputs are also given in the form of voltage values. So they are nominal values like 0 volt is considered as logic 0 or bit 0, and 5 volt is considered as logic 1 or bit 1. Similarly, if they produce the output which is around 0 volt, then that will be considered as logic 0, and if they produce 5 volt or around 5 volt, it will be considered as logic 1 or bit 1. So in general, the output that logic gates give is 1, but in special cases there can be multiple output bits also can be produced by such gates. One thing to note here is that there will always be a time delay between the inputs given and the output produced. So this is how the logic gates can be studied. The next gate is a NOT gate, and the IC number used for NOT gate is IC7404. So NOT gate is also a basic digital logic gate, which is also called as logical negation. It implements the logical negation. That means whatever input we provide, it inverts that input, and that's why the formula here is y is equal to a bar. So if we provide a, it will convert it into a bar, that is negation. So this is also called as inverter circuit because it inverts the voltage representation. So if the voltage value 0 is sent, so it will invert it to the voltage level 5. So this is why this is also called as the inversion inverter circuit. So this is the truth table. Here the input we require is just one. So with one input pin we can have two different values. So this input can be 0 or input can be 1, and as I said, this just inverts the input to the output. So if we provide 0 logic, it will invert it to 1, and if we provide 1 logic, it will invert it to 0. This is the pin diagram. Again, this IC also comes with 14 pins. So if the notch is on the upside, so all the left side pins will be from 1 to 7 and right side pins will be from 8 to 14. Whereas 7th is the ground pin and 14th is the positive voltage pin. Unlike OR gate and AND gate, this has total 6 gate in one IC, that is 7404. Because we require just one input and it produces just one output, so the first pin can be input and second pin is output. Similarly, third pin is input, fourth pin is output, and so on. So if I want to check the output, I need to connect my LED to the second pin, and I need to give the input like 0 and 1 to the first pin. So this is how the NOT gate can be implemented. So we will see how the NOT gate is implemented on breadboard.
Now let us see how the NOT gate is to be implemented. So to implement NOT gate, we require a breadboard, we require this power supply. This power supply is of 9 volt, but we require 5 volt. So I will be using this resistor in between. This resistor is around 220 ohm. You can use up to 1 kilo ohm. Now this is the IC that I need for implementing NOT gate. This is 7404 IC. So if you are going to hold up this IC like this, where this notch is on the upside, so you'll find 7 pins on this left side and 7 pins on the right side. You can start counting these pins from here. This is pin number 1, 2 and the 7th pin, then pin number 8th, 9th and this way 14th pin. So this 14th pin is connected to the plus VCC and this 7th pin is to be connected to the ground. This specifically for NOT gate. The first pin is input, second pin is output, then again third pin is input, fourth pin is output, then fifth pin is input and sixth pin is output. Similarly on this side also there are these NOT gates that can be used through this IC. So now I am inserting this IC like this and will be providing the power supply here to the breadboard in this way. So this breadboard is getting power supply now from this. Now since this power supply is of 9 volt, I will be using this resistor this way so that this 9 volt power supply will be minimized to somewhere around 5 volt. So I will be using my positive supply from this line. So this whole horizontal line has got positive connection and this whole horizontal line has got ground connection. So let me connect this IC 14th pin to the positive and 7th pin to the negative of this power supply. So now this IC is powered up. Now my output will be shown on this LED. So for this LED, this longer leg is always positive and this shorter leg is always negative. Also we can find out this through filament. This smaller filament is the positive and this broader filament is the negative. So I'm using this LED here this way. So I need to connect LED as well. So LED's negative side will be connected to the ground and LED's positive is to be connected to the output of the gate. So as I said, for a NOT gate, the second pin is the output and first pin is the input. So I'm using this pin as input. So this is the input. So right now the input is high because it is open and which is in air. So if I'm going to put this input to this 0, it will invert this input and the output will be high. So if this input is going to be 0, that is negative, the output will be high, and if the input is going to be high, the output is going to be low. So this is how the NOT gate is to be implemented. Similarly, I can use the next combination of this NOT gate. So I was using first pin as input and second pin as output. Now I will be using third pin as input and fourth pin as output. So you see, if my input is going to be low, the NOT gate will glow, and if my input is going to be positive or high, the output or the LED will not glow. So this is how NOT gate can be implemented using gate or using IC 7404.